All right, guys. So with the Dune buggy all done and everything working well, changing the clutch out, I figured it was probably a good opportunity to go over different types of clutches that Volkswagen used in air-cooled cars, the different sizes, the different years that use different sizes, and give you an overview of all the individual parts of the clutch, how they work, and what to look for, and how to know if a clutch has gone bad or starting to go bad. We'll maybe even talk about performance clutches just a little bit. All right, guys. So on the bench, I've got a bunch of clutch parts. And I figured to go through this, it probably makes sense to at least give you the definition of what each part is quickly before we jump into each part in detail. Just so that it kind of all makes sense. And here in front of me, I've got a flywheel. What a flywheel is it's literally a giant piece of steel. It's got some good weight to it. It has a starter ring gear going around the outside edge. And what that's used for is when you turn the key, your starter engages with this, rotates, and starts your engine. On the inside of this flywheel, you're going to see a flat surface. This particular one's not in great shape, but regardless, there's a flat surface in here. This flat surface, this is a friction surface. The point of this surface is to have the disc sit on top of it. And here is a clutch disc. And just like its namesake, it is a disc. It has a friction material. I'm going to say it's similar to a brake pad. It is not the same actual material, but you can think of it that way, as it's similar to a brake pad. It is designed to wear down as you use the clutch. Obviously it wears down a whole lot slower than most brake pads do, but the idea of this, what happens here is you've got a spline in the center. Your transmission input shaft goes through this spline. So this disc is sitting on that input shaft that's sticking out of the end of your transmission, between your engine and transmission. This disc is fixed. It can't move other than rotating with that shaft at the same time and the same speed as that shaft. Now your flywheel being mounted to the engine is going to rotate at the speed that the engine is rotating at. So if we put this disc inside here, we've got a friction material on a friction surface. And then our next component, we've got a pressure plate. So this pressure plate has its own friction surface, which obviously is to mate with the other side of this disc. And that's going to sit inside of here. This pressure plate, the way this works is it's spring-loaded. Just sitting here doing nothing, it wants to be in the outward position. You can see, or maybe you can see, there's a gap in here. So to tighten this plate down, it's actually going to preload it even more. And the way this works is you push into the center. When you push into the center, this whole disc internally will come up and it will lift this friction surface off of this disc. And this gets bolted to the flywheel. So with the engine running, your pressure plate and your flywheel are rotating at the same speed as the engine all the time. Your disc, if you step on the clutch, your disc is going to be free to just stay in one position in there. So if you're not rolling down the road, if you're stopped and the engine is running, that disc will be stationary while your flywheel and your pressure plate are rotating at engine speed. All right, when we talk about the different clutches that are used on air-cooled Volkswagens, they basically will list them by size. Obviously, there's an application for every size, but when you look at it and someone says you need a, say, 200 millimeter clutch, which is what this is, a 200 millimeter clutch, what you're measuring to determine that that's what this is you're going to measure the disc itself. You're not going to measure the inside of the pressure plate, none of that. You're just going to measure the disc. I have a ruler here that's metric. So if we go straight across the disc, we'll see this is ending at 200 millimeters. So that's the size of this clutch, is a 200 millimeter clutch. There are various other sizes that were used throughout the years of Volkswagen production. I'll add a chart in here so that you can see the various sizes and what years and models go with that size. Okay, so when we look at Type 1 200 millimeter clutches, you will hear and read that there is an early clutch and a late clutch. So here we have an early clutch, here we have a late clutch. Let me show you the differences between these, and it's mostly, the disc is pretty much the same. It's mostly the pressure plate and the throwout bearing. So the clutch throwout bearing on an early clutch is going to have these two ears sticking off. The ear has a hole in it, and the way it is mounted, it uses a clip. The clip goes through and attaches to the clutch arm. And then on the pressure plate, you're going to see you have a disc on top of this surface here. So now if we look at the late clutch, you'll see that this clutch has an ear on the side, on each side with a built-in spring. So you can see the difference between these, early and late. And now the pressure plate of the late clutch looks very similar to the early clutch, with the exception that it doesn't have this ring on here. And let me bring you over to a couple transmissions and I'll show you why it doesn't need this ring. All right, so we've got two transmissions here in the same position that those clutches were. We have an early and we have a late. So if we look at the two throwout bearings, you can see here's the ears and here is the peg style. I call it peg. I don't know if that's really a general term, but you can see this is a peg sticking out the side of the bearing. And you can see the clips I mentioned going out and around the side here versus the clip that's built into the back end. So this change happened somewhere in 1971, in the early part of 1971, possibly the late part of 1970. Pretty much with the change to a dual port engine is pretty much when this change happened. But that's never a guarantee. Just because you have a dual port in a car, it doesn't mean you're going to have this transmission. Just because you have an early transmission doesn't mean someone didn't convert it to a late one. And the difference, if you look, where I had mentioned that the pressure plate has the ring on it and it doesn't on the late one, you can see there's a sleeve right here. On this one, there is no sleeve. You can just see right back into the transmission where the shaft goes into the transmission. The reason for that is this is a locating sleeve. And the clutch bearing rides on it in and out when you step on the clutch. It twists this rod and it brings this forward and back. Because this doesn't have a locating sleeve, it's able to move just slightly around. So it has the collar or plate on the pressure plate that gives it a little bit of room to kind of catch where it needs to, and it kind of self-locates when it gets to that point. All right, so here's another transmission up on this shelf, and here's that locating sleeve. So you can see it's got three nuts, there's studs in the transmission that stick out, and it mounts onto there. So you can kind of see the difference here between that and the transmission that just basically has nothing inside here. You could just see the seal exposed. But this is a good way to look at it. Your clutch arm kind of comes forward like this when you step on the clutch, and the bearing would ride up and down on this sleeve. Okay, to get an idea on a flywheel, what happens with a flywheel, we've got ourselves a Volkswagen engine sitting here. Here's our flywheel. Here's the friction surface I mentioned, and here is our gland nut. On later stuff like buses, you will have bolts going around here holding this on, but all your type 1s, type 3s, and earlier type 2s are going to have a gland nut like this. All right, so to further look at the flywheel, you notice that there's 4 holes in the middle of this flywheel going around. You've got a center hole, and you've got 4 holes there. These are called dowel pins. This is a crankshaft. This is what's inside your engine, and you've got each one of these is where a rod sits or a bearing sits, and this rotates when your engine's rotating. These 4 holes will line up with these 4 pins, and then you'll have your gland nut, which is just a really big, it's called a gland nut, but it is really basically a bolt that's going to thread on after your flywheel. You torque this thing down, and then this is all inside of the engine, flywheel hanging out the back. Okay, so your clutch disc, your friction portion of your clutch, the part that is designed to wear out. There are pretty much two styles when it comes to a disc. You've got one side here that is a sprung disc, and then you've got a solid disc. And what this is you'll see this, there are a series of springs going around this disc. And you may have more, you may have less, depending on the manufacturer and you know, the year and everything of it. What this is it's a two-piece. So you have a rigid part in the back, and then you have a forward part. And when you release the clutch and it begins to grab, there is a little bit of movement that is allowed here. And what that basically does is it gives you a little smoother engagement. These are really ideal for lower horsepower, you know, stock Volkswagens that are used on the street. If you're not running around doing burnouts and you know, racing and anything else that you're doing, this clutch is perfect for that. They disengage really clean and easy. It makes for a very enjoyable, easy driving car when you're at stock power. And you can run one of these with a bigger engine. It just depends on your driving habits and how you're going to use the car. So this is a rigid disc. And as you can see, it's a solid disc. It's all riveted on there. Doesn't have any springs. So this is rigid. As soon as this clutch disc starts to grab, there is no vibration dampener. There's nothing in here to move this. Now, that's not saying this is a performance disc, because it's not. This is also a stock disc. It is just a different type of stock disc. This is more of a personal preference type thing of what you want to do with the car and how you want to use it. If you ever want to drop the clutch quick and kind of take off from a light or anything like that, you're better off with a rigid disc. Because what'll happen if you drop the clutch quickly with a sprung disc is you'll actually get a little bit of you'll feel a little bit of I don't want to say a wobble, but that's kind of the best way I can describe it. You'll feel a little bit of jump as this kind of moves back and forth. Now, the thing with a solid disc is you're also going to get, on easy releases, you're going to get a little bit more of a harsh engagement. So if you're somebody that wants to attempt to do a burnout, or you want to, you know, kind of hot shot the car around a little bit and accelerate quick and stuff, this disc is great. But realize you are going to have just slightly more of a rough engagement, say taking off from a light easily when you're just driving the car as a normal car and going easy with the car. If you like to do things like, say you drive in a parade often, you go in parades, that type of driving, this is the clutch disc for you. If you like to buzz around in the car and you know, rev it up and accelerate through things, then this is probably a better disc for you. It's a tough thing to recommend which one's better, because it really is based off of your driving habits. And once you drive one or the other, you'll understand if you need the other one or not. But at that point, it's in the car. So it's kind of one of those things when you take it off, if you enjoyed the way the car drove and you're changing out a clutch, at that point, it's a good idea to stick with what it was. If there were things that the clutch did that you didn't like, whether it was a little bit of a hop or a rough engagement, maybe this isn't for you and you switch to a sprung disc. Okay, so on to the pressure plate. So now your pressure plate is putting a ton of force on that disc to squeeze it between itself and the flywheel. There are a few different style pressure plates that have been used over the years that basically all kind of do the same thing, just slightly in a different way. Your early Volkswagens would have left the factory with a spring type pressure plate. And if you look at this pressure plate, you've actually got, this particular one has 6, but it has 6 individual springs that are inside of this in a series of arms. Here's your friction surface. This one's pretty small. It's a 180. millimeter, but how it works is the same as the rest of these. When you push down inside of here, I can't do it because I don't have the force in my hands to do that. When you push down in this, the center is going to drop down and it's going to push. It's not a lot, but it's going to pull this plate back in away from this outside surface that is mounted to the flywheel, releasing your clutch disc. So now we move over to this pressure plate, and this is a diaphragm type pressure plate. Same idea, it just doesn't use a spring going all the way around. The spring is putting pressure down. Instead, the diaphragm pressure plate has, and I don't know if I can really show it to you, but there's basically it's kind of a leaf spring, I guess you can call it in this case, that's going around this edge. And when you, same situation, you got all these fingers up here on these. When you push down in the center, it's going to release and it's going to pull this friction surface back towards the middle of the pressure plate, pull it back, releasing the disc and allowing it to move. Just because you've got a sprung plate and a diaphragm plate, then you've got this thing. So this is still a diaphragm plate. It is not a spring plate, but it is older. This one's, I don't know what brand it is, but it's a significantly older pressure plate. Same idea though. It has a diaphragm that's pushing this friction surface onto the face of the clutch. When you push down here, it's going to bend these up the same way these arms bend, but it's a different spring inside. This is a diaphragm. This is a coil spring, let's call it, regular style spring. But these are the same. This is an interchangeable, well, this isn't because this is a 200 and a 180, but these are interchangeable as long as you're sticking within the bounds of your 1971 change from early to late. These are all early style. They go with an early style transmission. This is the only late one I have here on the bench. But that's a pretty standard. When you get into buses and other later Volkswagens, they will all be this way. Early stuff is all going to be this way. But I just wanted to point out, just because you pull your engine out and you go to change a clutch and you have a spring style pressure plate, it doesn't mean that you can't replace it with this. You buy a kit, it gives you the correct bearing, the correct clutch disc, and the pressure plate for that particular year, and that's going to be interchangeable. This will go away. There aren't too many sellers anymore that are selling spring-loaded plates like this. They're almost all diaphragm style because that's the style that 99% of cars on the road are using, a diaphragm style, and this is more of a earlier technology. Nothing wrong with it, still functions perfectly fine. It's just a different manufacturing process, and everybody's gone to this so that they can just make all cars the same type of process. All right, so last part of our Volkswagen clutch components is the clutch release throwout bearing. And like I had shown you, there's an early and a late. We're going to focus on just this particular one for right now. And I'm going to use this pressure plate. So like I showed you, this sits inside of a transmission, and you can push this out by stepping on the pedal. And what that's going to do is that's what engages here and pushes this in on the pressure plate, releasing the disc. Now, why does it need to be a bearing? Because this is rotating. Like we've said, with the engine, this is rotating. So if you're at 1,000 RPM on your engine, this plate is running at 1,000 RPM. If you were to just push against this with a solid piece, it would wear both pieces down very quickly. So now you've got a bearing in here, and this just sits very slightly off, so it's not actually rotating all the time. It's just sitting there on that fork, the clutch fork. And when you step on it, it comes in, makes contact. This is rotating, so this begins rotating inside. This inner portion right here begins rotating. And as you push, it continues to rotate, pushes in, engages or disengages the clutch, rather. You come back out, there's a small gap in there because you don't want this rotating the entire time the engine's running because you'll wear this out. The intention of this is to only be making contact when you're stepping on the pedal and when you're not stepping on the pedal. That's why when we look at our specifications on your clutch pedal and they tell you that there is a free play, an amount of free play that you should have on your pedal, that free play ensures that this bearing is not making contact until you actually get past that free play and start the bearing coming in and making contact. All right, so performance clutch parts, do we need them? Do you need a performance clutch or do you just need a stock replacement? So let's talk about some differences between performance parts and regular parts. So to start, we've got our regular flywheel. I don't know what that weighs, but it's pretty heavy. And then here I've got a lightened flywheel. So this one weighs a few pounds less than this other one. And if I flip it over, this is a manufactured one. It hasn't been machined. You'll notice one, it's an 8 dowel. So we talked about this having 4 dowels mounted to the crankshaft. This has 8. So as you get into performance parts, you have 8 dowels instead of 4. Those dowels come in, and as you can imagine, they'll hold that flywheel on there better rather than 4 trying to spin itself off. So if we flip this over and flip both of them over, you'll see this edge out here is smaller. Same size flywheel, it's a 200 millimeter flywheel, but you'll see that it has less material around this edge than the original stock style flywheel. Otherwise, it's exactly the same. It's lighter. I mean, I can pick this up with just a thumb. This one I can, but it's got some good weight to it. And then we go even further than that. So this is, I'm not sure exactly the brand or anything of this flywheel. It's just one I've got hanging around here. Lightened flywheel, you go from the lightened flywheel to the extremely lightened flywheel, and you can see this one's way back. This is also a manufactured one. Somebody didn't machine this down. This was made this light. And this one weighs, I mean, this is very light. Even compared to this one, it's got to be a good 5 pounds lighter. There's nothing to it. That's pretty much a full race flywheel. Okay, so why do you even think you want a lightened flywheel? The idea of a lightened flywheel is it allows the engine to rev up faster due to the reduced rotating mass. So the engine has to work to rotate this heavy flywheel. The lighter you make the flywheel, the less work that engine has to do to rotate this flywheel. Now there's good and bad to it. The good part of it is you rev up quick. You step on the gas and your RPMs go up really fast and everything's a little bit quicker to get going. You're not changing the amount of power that the engine has. Nothing is changing except for how quickly the engine is able to rev up, assuming other parts work in tandem with that. The problem with a lightened flywheel is if you don't have a ton of power, or you're on the lower end of the power scale, they can actually cause a rougher idle because this heavy flywheel helps keep the engine's momentum going at lower RPM. This lightweight flywheel is going to rev up fast and it's also going to drop down fast. So you can end up with a stumble or a rougher idle because of it. You can also, with this, the engine, you take your foot off the gas, the engine continues at a certain RPM for a little while as it slowly slows down. Not enough that you can notice it. You could watch a tachometer drop right off with this flywheel, but the difference in time here, and we're probably talking milliseconds, this one gives you it's a little easier to shift between gears and match RPM, where this one's going to drop off quick and you've got to shift very quickly because that's what this is designed for. It's designed for higher performance, faster revving. Okay, so the next performance part we talk about when we talk about clutches. We talked about our lightened flywheel. Now we've got our pressure plate. Our pressure plate, and as you can see here, we talked about a sprung style pressure plate. This has an extra spring going all the way around. So instead of having 6 springs, we've got 9. So this is actually able to put more clamping force on your disc. This is a fairly old, this is probably a 30-year-old performance pressure plate, but it is a performance pressure plate. It's never been used. It's just new old stock. And the idea there is we've got our flywheel, we've got our disc in there, and now we've got more clamping force. Now, do you need this? Maybe you do. Maybe you've got a lot of horsepower, maybe you don't. The idea with the performance pressure plate is that you are going to have more clamping force, less slipping of the disc. The trade-off for that is this is what's going to cause you to have a harder pedal. When you hear people talk about driving standard, driving a manual transmission, and they say, wow, the pedal is really, really hard. It takes effort to push in. That's usually because your pressure plate, the spring tension is very, very high. These obviously come in other styles. You can get a diaphragm style performance pressure plate, just like this one. It's not as easy to spot the extra springs, but it's going to be based on the specs of the manufacturer. So you're going to just have more clamping force, but it's going to look like the same as that type of style pressure plate. So that's your performance pressure plate. And then we move on to the disc. So when we talk about discs, we have a stock disc. This is the spring-loaded one. Then we have a rigid disc. I don't want to call them performance. This particular disc, though, is actually a performance disc. It has a different material versus a standard clutch disc. That material is going to grab better. It's going to grab a little more aggressively. And the point of that is when this is in here, it's a ceramic material on most of them. I'm not positive what this one is, but it's the one that mates with this red pressure plate. But this particular one, has a different material. So that's going to grab differently. Think about it. I'll bring brake pads back into this. Think about an aggressive brake pad versus a stock brake pad. You really can't tell the difference looking at them, but the material is made to grab quicker, harder, and clamp better than a stock material. It'll be less likely to slip. So now this material, obviously by doing that, it's going to allow for more wear of your flywheel, more wear of your mating surface on your pressure plate. But if that's what you need is a higher grade material or a performance material, then maybe this is the first step in getting a performance clutch. Now, if we jump from regular performance clutches to more of an extreme performance clutch, we have a 4-puck. This is a pretty old one. Again, I don't know if this has been in a car. Kind of hard to tell. These have a ceramic puck on each side going around. You'll see these with 4. You'll see them with 6. There's varying different levels of performance. This is pretty much the most aggressive clutch that you can probably buy, from a regular supplier on the internet or in a catalog for a Volkswagen. This clutch is not designed to drive this car every day on the street. This clutch is designed to drag race this car for performance driving, track driving, things like that. In order to start this car in first gear that has this disc in it, you are going to have higher RPM. You're going to have to slip the clutch a little bit probably just to get the car rolling, to get everything working. But what's going to happen is this disc is going to grab the mating surfaces of the pressure plate and the flywheel better than any other disc. And it may seem kind of crazy that you have less material, so why would it grab more and why would it have more force? And the reason for that is that with less surface area, when you clamp this between a pressure plate and a flywheel, all of your clamping force here is clamping down on each one of these pucks instead of being spread over the entire surface of a regular clutch disc. The other thing with a performance disc like this is you've obviously eliminated some weight. You can see how thin this piece of steel is. You can see it's got notches cut in. A lot of them you'll see won't even have any metal in here. It'll just have an individual little ear for each one of these pucks, or if there's 6, there'll be 6 ears. This particular one just has kind of the split there, but you're reducing weight even more. So when you combine this with a lightened flywheel, a performance plate, you've got a combination that's going to be very, very aggressive, and you're going to need a fair amount of horsepower. You're going to need a fair amount of RPM just to engage and disengage this. But why would we want a performance clutch? We would want a performance clutch because when you have a lot of power and you're forcing a car down the road, this disc at this clamping power, at this stock clamping power, will slip when you get to a certain horsepower level. You will actually have this disc will not clamp tight enough, and you will have engine turning, transmission not turning as fast, and you will be slipping, which generates heat, which causes problems and damages the friction surface on both sides. And really what it does is, if you were racing it, you would lose power and you would lose momentum, and you wouldn't be moving down the track or you know, a road course or whatever you're on. All right, so we've talked about all the various clutch parts. What are the signs that are telling you your clutch is going bad? So if we just go down the list, we've got noise. We have throwout bearing making noise, like I showed you. This is a fairly common thing that happens. You know, a car sits a long time or something. You know, the bearing, in my case, this bearing sat on the shelf too long, and it dried out inside. I used it, and it let go on me and made a ton of noise. Slipping. So your clutch slipping is a very obvious sign that you need a new clutch. So if we look at the stock clutch, like I mentioned, this will actually slip inside of here, and you will go to accelerate. What will happen is, and you can usually see this if you're in, say, third, fourth gear, somewhere in that range, and if you just floor it, you will actually get a slip. You'll see, if you have a tachometer, you'll see it, but otherwise you'll hear the engine rev up. But if you look at your speedometer and you feel it, you're not actually moving any faster, but your engine is revving, where when the clutch is clamped properly, you'll hear the engine rev up, but you'll feel the car moving forward faster, increasing speed as that noise and RPM is going up. So that's a big one, is most of the time when you're replacing a clutch, it's because this disc is worn out. When a disc starts to wear out, you may notice it in the clutch pedal. As I mentioned, you have that free play in the pedal. That free play will get closer and closer to the top of your engagement. So when you release the pedal, you'll feel the pedal come all the way up, and you won't have very much pedal movement left, and the clutch will be engaged already at that point. With a brand new clutch, you may get, say, you know, 2/3 of the pedal, 2/3 of the distance of the pedal, you'll feel the clutch engage and disengage just above that. As it gets older and more worn and more worn, this is assuming that your clutch is adjusted properly, you'll have the disengagement of your clutch will happen much higher on the pedal, and it'll get higher and higher and higher until it gets to a point where it basically just is slipping the entire time. And no matter what you do, it's like it never actually clamps. We've gone over all the different clutch parts. Hopefully this helps you out and kind of gives you some insight on which clutch you have. If you have a clutch sitting there and you're trying to figure out what it is, or if you've got a car that you need to do a clutch in, maybe it'll give you a little bit more information on what you need to purchase and what may work for you and may not work for you. But that's pretty much it. I want to thank you for watching the video, and if it was useful to you, please like and subscribe to see more videos on Volkswagens and other random stuff I got going on. Much appreciated. Thank you. Have a great day.